Hello everyone, welcome to the second lecture of chemical bonding. In the previous lecture, we have discussed the octet rule. So today we will be discussing the covalency. Let's get started. So what is covalency? Let's take an example of carbon. So carbon has 6 electrons. So what is the electronic configuration of carbon? 1s2, 2s2 and 2p4. Now according to octet rule, there should be 8 electrons in its valence shell to be stable. So valence shell should be filled, completely filled. Now, here, here, let me draw the orbitals. I have only drawn the valence shell. So I have here 2 electrons and here 4 electrons. Now, how many electrons are needed so that this carbon would get stable? So here we did a small mistake, that is 2 here. So did you any time see carbon and stable carbon ion? No, right? Because if carbon wants to be stable, then it should have 8 electrons in its valence shell. If it want 8 electrons, it should have more 4 electrons, right? So for getting those 4 electrons, carbon always forms a covalent bond. So what happens is, this is the ground state. Ground state means the natural state. Now this electron will jump here. This is called excited state. So if it jumps here, and what happens is 4 orbitals would be empty. So that you always know, you always uh, heard that only outermost electrons are involved in bonding. So what happens here is bonding happens. So 4 electrons are needed for this carbon. So it will bond, it will do 4 bonds. So it will form 4 bonds for 4 electrons, so that it would get 4 electrons and can be stable. So for carbon, achieving 4 electrons is also difficult, and losing 4 electrons is also difficult. That's why it forms a covalent bond. Let's see some examples. Example, CH4. CH4, it has 4 electrons in its valence shell, right? It has 4 electrons in its valence shell. So let me draw and show you. 1, 2, 3, 4. So it has 4 electrons in its valence shell. So let's mark 4 electrons. So we have already marked. Now we have 4 hydrogens around it to form a bond. So why hydrogen also forms a bond? To complete its octet. So octet rule is exception for hydrogen, because if it has 2 electrons also, it would uh, be stable, because the valence shell is filled. It's exception, but logical exception. It's very logical. Now hydrogen also puts 1 electron forward. Carbon has put the electrons forward. Hydrogen also puts its electron forward. Now what happens is, these electrons get paired. So that the necessity of hydrogen is cleared and fulfilled, and carbon necessity also fulfilled. These electrons are shared among these 2 atoms. So have you understood? This is covalent bond. So How many electrons are needed for carbon? 4. So that this is covalency, right? Covalency is equals to, note it down, covalence means number of covalent bonds formed by an atom. Carbon is able to form 4 bonds because in excited state it has 4 unpaired electrons. So simple, right? So let's talk about CO2. So we have two oxygens. So oxygen can form 2 bonds. So if carbon has 2 electrons, oxygen has 2 electrons, pairing occurs, so double bond forms. So this is covalency. Now oxygen needs 2 electrons and carbon needs 4 electrons. So covalency of oxygen is 2 and carbon has covalency 4. So after this lecture you have to take some atoms and write their covalency. Now what is a lone pair? A lone pair is, now carbon, we have oxygen, it has 8 electrons, right? And its excited state would be like this. In last shell large shell ground state would be like this. It would have 6 electrons, right? 1 2 3, we have 2 here, right? It would be like this. Then it needed 2 more electrons here, right? Here 2 more electrons. So it would make 2 bonds so that it would get 2 more electrons. Now what are lone pairs? Lone pair means which are not involved in bonding. These electrons, these valency electrons which are not involved in bonding are known as lone pair. So we would have lone pair like this. We would represent them like this. We have 4 lone pairs. So this is lone pair. So have you understood the covalency and lone pair? So that's all for today. We have discussed the covalency. So this is a very small topic. So more you do this self-study, more efficient your work will be. If you will not do your self-study, if you not analyze the atoms, and if you not, I have given one example. So you have to take nitrogen, phosphorus and do it by your own. Find the covalency by your own. If you understand by your own, your efficiency would increase. So let's meet in the next lecture. Till then, keep practicing. Bye.